Yeah, maybe some words to me as a person. My name is Veronika Gaube. I'm working in the Institute of Social Ecology at the Boku University in Vienna. I'm from a background, I'm ecologist, so I studied biology and ecology, but when I started to do my PhD already, which is 20 years ago now, I'm since then working in the field of social ecology. Yeah, and I'm in contact with many others since many years in the process of developing and establishing the research infrastructure of ELSTER. But turning to my presentation, when I saw that I'm one of the first speakers today, I decided to design my presentation more conceptually, proposing how integrated and participatory models can meet the needs of transformative change, rather than presenting empirical results. I think there will follow many excellent talks on empirical work, and this is why I'm more focusing on introducing a tool and some concepts. First, I would like to outline the definitions of social ecology and transdisciplinary research. They are used very often in combination, but originally they are coming from different strengths. So, socio-ecological research analyzes the interaction between social and natural systems. In many cases, social ecology develops conceptually as well as practically information systems on the environmental consequences of human activities, of societal activities. And it is research on ecological and socio-economic aspects of sustainable development at different states, at different levels. So social ecology works on the local level, regional level, but also on the national and global level, always with a focus on socio-ecological transformation. Transdisciplinary research focuses on societal problems, aiming for, based on one of the first social scientists that was involved in social ecological studies, Thomas Jahn, whom I'm citing here. He's always talking about aiming at producing 3 types of knowledge, and I would like to briefly introduce these knowledge types, because I think they're really important in order to get an understanding how maybe from science we can achieve better impacts in the real world. So the first knowledge type is related to system knowledge. System knowledge is an analytical and descriptive knowledge type about the actual state of the system, the ecosystem, but it's also the social system. So it's the analysis of what are the systems about, what are the interactions within these systems. The second type of knowledge is related to the target knowledge, which describes knowledge about the desired future. So how should we develop a system in order to come to a desired future vision? And the gap between the system knowledge and the target knowledge is related to transformation knowledge, knowledge about how can we move from the actual state where we are, outlined by Nicholas also, to the desired state, or more desirable state. And this triangle on the right also describes this relationship between what are the facts produced very often in science, what is the relation to values and agency. Facts are strongly associated with system knowledge, so they belong to the sphere of science, where scientists are the most important actors and the most credible actors, and they try to give answers to the question, what is, what's going on, what can we measure, what can we see and learn. The values refer more to the target knowledge, and they are generally in the sphere of political actors, depending on public debate on the one hand, but also government and governance structures. And these values address the question of what ought to be, where should we go forward, what should we aim for. And finally, agency, which is the capacity to act in a purposeful way, is associated with the transformation knowledge and is linked to the sphere of practice, which means to the sphere of practitioners who know how things are done and need to be done. So agency tries to answer the question of how to come from one state to the next. And these 3 knowledge types are equally important to foster societal change, and they are, of course, interdependent. And very often science-specific projects focus only on one type of knowledge production, or maybe two. But I think it's really important to keep them all in mind, how important they are in order to achieve transformative change. And maybe missing knowledge in one project has been generated in another project, and synergies can be used in order to achieve changes in the real world. But I also would like to point out to two particular traps, which are important to watch out. First, ignoring how important it is to co-produce target knowledge together with the stakeholders can mean that implicit assumptions very often are produced by scientists of a desirable future or desirable goal is at contrast with the aims of different stakeholders. So this is something that we always have to be aware of. And the second trap I would like to mention is generating more and more system knowledge, something where science tends to do so with no plan for using it for effective change again cannot lead to any change in the real world. And building on this understanding of transdisciplinarity in social ecology, I would now like to give a short introduction in the empirical work that we do. And in many of our projects, we develop integrated participatory models. With them we try to generate all three types of knowledge, at least to some extent. And our research questions, content wise, are well placed at the center of the scheme from the global Nexus scheme, where we investigate how external forces, drivers, biophysical drivers like climate change, but also socioeconomic drivers, political drivers, impact land use and land use patterns, in particular agricultural production, but also in our case forestry. And we investigate how this affects, for example, water availability, water and soil quality, and ultimately biodiversity. However, in our project's design, we go well beyond this, as we also include risk management elements as a novel aspect of its and its feedback loops to develop regional solutions in a transdisciplinary manner together with stakeholders. By doing this, we address the critical interplay between social and natural processes, including also governance and vulnerability. So we focus on governance like climate risk management as a systematic approach to proactively address the challenges posed by climate change. And we also focus on vulnerability, where environmental and socioeconomic forces influence both the exposure but also the vulnerability of societies. And as an example, you can see here the map of Austria and Switzerland indicating the exposure rate of residential buildings to flooding, for example. But very often responses to these challenges focus on traditional technical mitigation measures, such as retention basins. But these measures very often can conflict with other societal and biophysical goals, such as improving biodiversity, but also they can be in conflict with important directives like the Water Framework Directive or the Nature Restoration Law. So what is really needed for a fundamental change is a fundamental change in the governance structure, but how to implement this is still a big challenge and very often still unclear. In the majority of our projects, we work in a specific region in Austria, which is the LSTER platform Eisenwurzen. I'm not going in detail what is an LSTER platform. This will be given by another presentation this afternoon by Daniel Ornstein. But the Eisenwurzen is a region in the middle of Austria in a pre-Alpine region. And of course, it's not one of the most affected regions so far from climate change in Europe, especially in comparison to Mediterranean regions. But also we can observe changes going on. And this is why we also started to focus our research on climate-related water and land challenges, starting in that region. And you can see here on the graph since the 1980s that the river temperature is rising more than 1 degree, which has an impact on the aquatic systems and reduces biodiversity in the aquatic systems. And at the same time, agriculture, which is the most important economic sector in this region, faces longer droughts, higher temperatures, and less water. And at the same time, extreme events like heavy rain and droughts is increasing. There are troubles with infrastructure, communities are threatened, and also food production, of course. So what is needed also there is a proactive, and in this specific situation of this region, we are still talking about a proactive, integrated approach to combine water management, agriculture, and other stakeholders in order to boost resilience through nature-based solutions like flood protection, erosion control, land restoration, of course, and irrigation systems, which is really new in that region to implement irrigation systems there. So one important type of solutions is related to nature-based solutions, which I just would like to use as an example to demonstrate how complex in general the implementation of new governance structures can be. Nature-based solutions are promoted as a risk reduction strategy to support climate change adaptation, and they aim to provide multiple benefits, but also co-benefits, such as increased biodiversity, improved water quality, but also improved mental health, for example. But the challenge lies in the implementation process of new governance structure, which is based on the environmental conditions of the catchment area, for example, at the same time based on social interactions, financial resources, and institutional settings. And why is it such a challenge? Nature-based solutions are one of many measures that require privately owned land to be converted, and this very often leads to an increase in land use conflicts. And it's shown here in this schematic figure. Land uses can be affected, and they are also infected in our Alpine region already, by droughts and floods, and in most cases by both in the same year. And they are also part of a social system where they communicate and negotiate reactions to these challenges with other land users, but also with decision makers. And in most cases, co-benefits and trade-offs of solutions are distributed unequally, for example, between communities located upstream or downstream. And this is where social justice issues arise in relation to distribution, redistribution of different kinds of resources, of access to resources, but also participation and power, of course. And overall, this means that there is an increased need for communities to participate in the co-creation of solutions, which moves far beyond only consultation or information sharing. And for doing this in our projects, we develop these so-called integrated socio-ecologically modeling frameworks, which I would like to talk you through now. This is a scientific tool used to determine the hydroclimatic impacts on land use decision-making in our specific region. In the Eisenwurzeln here, you can see this located in the center of Austria. The modeling framework is a combination of different models. It consists of a land use and decision-making model, which simulates, based on assumed changes, on the biophysical and socioeconomic framework conditions. So, for example, based on changes in the climate or the impacts of extreme events, but also changes in the socioeconomic framework conditions, like changes in the subsidy systems, prices, but also internal motivation factors of farmers. And these decisions of individual land users are then simulated and represented as clearly spatially explicit land use maps. These are the outputs of the land use decision-making model, and at the same time they are the inputs for the hydrological model, SWOT, and SWOT is then linked with an ecological model. SWOT and ecological model together simulate the effects of land use change in combination with climate change and determine ecosystem conditions. The modeling framework calculates different indicators, including ecological indicators like water balance components, water quality, but also the socioeconomic situation of land users. So it also calculates, based on the different scenarios, what does this mean for the income situation, for the work situation, for the living condition of farmers. And these indicators enable then the comparison of the effects and trade-offs of different solution scenarios. In order to set up this integrated modeling framework, we work in a participatory modeling process together with stakeholders to identify future visions of justice and analyze the impacts of those. And the process works as follows. A group of selected actors, which in most cases are not many, but representing various interest groups, are invited to negotiate fair solutions. And once one first initial agreement has been reached, this agreement is translated into so-called decision trees, which is the core of the land use decision-making model. And these decision trees are based on if-then assumptions, which we develop together with the stakeholders on paper through a collaborative process, and then implementing, translating into the land use decision-making model. The coupled model framework shown before then starts to simulate the different indicators also presented before to assess the success of the future scenarios. And the results of these model runs are then used in the next round of discussions to facilitate the development of new solutions, maybe fairer solutions, which will be implemented in the model once more. And in most cases, this iterative participatory modeling approach will take place up to 3 times. In an ideal world, and I'm not saying that we are really achieving it in every project, but we try to achieve it, and aim for it is that this process, which normally takes up to 3 years, leads to a better understanding of system behavior among scientists and stakeholders, and the tool itself, at the end, is a scientifically sound tool and method that enables different scenarios to be calculated and used also for scientific purposes. So far, what we have not done so far is to implement also negotiated solutions in the field, on the fields of the farmers in the same projects. But however, we hope to integrate this in upcoming projects that are embedded in living lab approaches in the near future. To summarize, how can integrated participatory modeling support the generation of the different, in the beginning mentioned, knowledge types? It supports system knowledge by integrating natural and social science data equally. It integrates quantitative and qualitative data and simulates the relations between different system components, the natural system and the social system. It supports target knowledge by allowing for a better understanding of effects of different targets or solutions negotiated by the stakeholders, and it supports transformation, or can support transformation knowledge, as the outcomes of the negotiations provide a deep understanding of enablers and inhibitors of transformative activities in the ecosystem, but also in the social system. So to conclude, interdisciplinary science and tools done poorly can undermine trust in science and can really be a problem. But done well, based on a long-term relationship between researchers and communities, can provide orientation and leadership in processes of societal transformation. And with this, thank you for your attention.